So I have the equation r times the second derivative of u over dr squared plus du over dr is equal to 0. And I am asked to show that u of r is equals to u of o times ln of r over b minus u1 times ln of r over a all over ln of a over b. So uh, first this equation we have to multiply both sides by r. So we have r over dr squared plus du over dr is equal to 0. So we have r squared times d squared u over dr squared plus r du over dr is equals to 0. So since we have r, and r, so this is an Euler Cauchy equation. So first we let u is equals to r raised to m. So u prime is equals to m times r raised to m minus 1, and u double prime is equals to m times m minus 1 times r raised to m minus 2. So we substitute this to the general equation. So to the new equation, so we have r squared times m squared minus m times r raised to m times r raised to negative 2 plus r times m times r raised to m times r raised to negative 1 is equal to 0. So 2 plus negative 2, this would be cancelled. Same thing with r raised to negative 1. So we are left with the terms m squared minus m times rm and m times rm. So factoring out r raised to m, we have m squared minus m plus m is equal to 0. Again, cancelling negative m and plus m. So, and dividing both sides by r raised to m, we have m squared is equal to 0, and m is equals to 0. This is a repeated root. So this is case 2. So case 2 equation goes like y is equals to c1 times r raised to m, which is 0, plus c2 times ln of r times r raised to m, which is 0. So we have c1 plus c2 times ln of r. So u of r is equals to, by the way, u1 of a. This is the first condition. So c1 plus c2 ln of a, and we have ub is equals to c1 plus c2 ln of b. So this would be u sub o, u sub 1. So solving for c1, we have c1 is equals to u sub o minus c2 ln of a, and solving for u1 is equals to u sub o minus c2 ln of a plus c2 ln of b, and transposing u to the right side of the equation, we have u1 minus uo is equals to c2 times ln of b over ln of A. So now finding for C2, we have U1 minus U sub O over ln of B